Hook effect. The hook effect, also called the high-dose hook effect or prozone hook effect, is not unique to prolactin. It can occur with many two-site sandwich immunoassays when the analyte concentration is extremely high. Classic exam examples. Prolactin, the most important. HCG. PSA. Ferritin. Thyroglobulin. AFP. The hook effect is one of the most important laboratory pitfalls in endocrinology because it can produce a falsely low prolactin result in patients who actually have extremely high prolactin levels, particularly those with very large prolactinomas. To understand the hook effect, it is helpful to first review how a sandwich immunoassay normally measures prolactin. The key is to understand what the machine is actually counting. Step 1. Imagine there are only 10 patients' prolactin molecules. The test uses two antibodies. A capture antibody fixed to the test surface. A detection antibody has a signal that the machine can detect. The machine does not count prolactin molecules directly. It only counts complete sandwiches. Capture antibody, prolactin, detection antibody. Only this complete sandwich produces a signal. Step 2. Normal prolactin level. Suppose there are 100 capture antibodies, 100 detection antibodies, 10 prolactin molecules. Each prolactin molecule can easily bind both antibodies. Capture, prolactin, detection. 10 sandwiches are formed. The machine counts 10 sandwiches. Everything is accurate. Step 3. High prolactin level. Now suppose there are 100 capture antibodies, 100 detection antibodies, 80 prolactin molecules. Still, plenty of sandwiches can form. The machine detects many sandwiches and reports a high prolactin level. Still correct. Step 4. Extremely high prolactin hook effect. Now imagine there are 100 capture antibodies, 100 detection antibodies, 10,000 prolactin molecules. There is prolactin everywhere. As soon as a capture antibody touches one prolactin molecule, it is occupied. Likewise, every detection antibody also immediately binds a different prolactin molecule because there are thousands available. For example, capture prolactin, detection prolactin. Notice something important. The capture antibody and detection antibody are no longer attached to the same prolactin molecule. Therefore, no sandwich is formed. Why can't they join together? Imagine two people trying to shake hands by holding the same ball. Normally, person A and person B both hold the same ball, creating a connection between them. Now imagine there are thousands of balls scattered on the floor. Person A picks up one ball, while person B picks up a different ball. Because they are each holding a separate ball, they never connect with each other. No connection is made. This is exactly what happens in the hook effect. When there is an extremely high concentration of the analyte, the capture antibody and the detection antibody each bind to different analyte molecules instead of binding to the same one. As a result, very few antibody-analyte antibody sandwiches are formed, leading to a falsely low test result. What does the machine see? The analyzer is programmed to count only this. Capture, prolactin, detection. Since very few sandwiches exist, the machine thinks there isn't much prolactin. It reports a low value, even though the blood actually contains a huge amount of prolactin. Why does dilution fix the problem? Suppose the patient's blood actually contains 10,000 prolactin molecules. The laboratory dilutes the sample 100-fold. Now the machine sees only about 100 prolactin molecules. Suddenly there are no longer excessive prolactin molecules competing for every antibody. The antibodies can bind the same prolactin molecule again. Capture, prolactin, detection. Many sandwiches form. The machine now detects the correct number of complexes and reports the true very high prolactin level. A simple rule to remember is that normal or moderately elevated prolactin levels allow the formation of many complete antibody-prolactin antibody sandwich complexes, enabling the assay to produce an accurate prolactin measurement. In contrast, when prolactin levels become extremely high, the capture and detection antibodies become saturated independently by different prolactin molecules. This prevents the formation of sufficient complete sandwich complexes, causing the assay to detect fewer complexes than are actually present. Consequently, the laboratory reports a falsely low prolactin level, a phenomenon known as the hook effect. A useful way to understand this concept is to remember that the analyzer does not measure prolactin molecules directly. Instead, it measures the number of complete antibody-prolactin antibody sandwich complexes. When prolactin is present in overwhelming excess, the formation of these complexes is impaired, causing the analyzer to underestimate the true prolactin concentration.